So in this lesson, we are going to look at authorization. Mostly, authorization is the next step after authentication. So authorization defines what you can do in a system once you have identified that it is yourself. In certain cases, it's much more complicated than authentication itself. And this is one of the most important concepts when it comes to corporate security. Not everyone has the same access. So we are going to look at the concepts first, then we will look at an analogy, very solid analogy of an airport. And then we will look at how authentication, authorization, all these things are implemented in IAM, AWS IAM. It's just a typical example we are going to look at, a production kind of implementation of authorization, just to get a feel of the actual implementation. Being said that, let's get into the topic. Authorization. It is also called role-based access control in a technical manner. So we are going to discuss both of these things in one single shot. Role-based access control. Some people name it RBAC and things like that. Instead of juggling around the jargon, let's get into the topic. Pretty much what this is all about. Authentication. We have seen, and most of you are familiar with authentication, but authorization part is probably slightly new to you in the sense that mostly it is present in enterprise softwares, which is used by big companies, fairly large companies. Even small companies doesn't need much of a authorization workflow. You'll understand when I explain what it is, why we need this specific thing for big companies and not small companies. So what is our agenda of this particular lesson? We are going to discuss what authorization is all about. Then what we are going to do, we are going to see a proper production example of authorization and RBAC in general. We'll discuss some of the other products which uses all these things, including the history of all these things. We'll talk about Active Directory and things like that. Now, to start the discussion of authorization start at the end of authentication. Once the user is authenticated, the authorization workflow normally starts. It is always about a user who is authenticated. He has proven that he is someone he is claiming to be by XYZ means. Now, what he can do, that is what authorization is all about. What that user can do, we have proved he is what he is claiming to be using OTP, password, certificates, all kind of things. We have verified him. It is very common in our daily life. Let's take the example of an airport. So there are pilots who fly the plane. Then there are air crews. Then there are passengers. Then there is airport staff. This is airport staff. And there are security personnel. And there is police and other kind of government security enforcement, law enforcement. So these are different types of groups available in an airport scenario. So many of them does different things. Now, what are the things it protects? What are the things an airport has? Now, the airport premises. Guns, pretty sensitive stuff when it comes to an airport, guns. Then the plane, the airplane. The plane cockpit. Plane food storage. The food storage inside the plane. Then there are so many things you can imagine. So how do we maintain the access to all these things? Does pilot have access to guns? No, pilot doesn't have access to gun. Security professionals has access to the gun? Maybe yes, maybe not. But law enforcement does have access to the gun. Let's give that access. Law enforcement has access to the gun. Airport premises, pretty much everyone has access. Everyone has access to airport premises. Passengers. Let's put anonymous. They are not passengers. They are simply people. Anonymous. By the way, anonymous is also a role or a type of people who are not authenticated. They have not proven whom they are. For example, Sydney Airport here in Mascot. Unlike some of the airports in India, anyone can enter into the airport. There is no verification. In India, that's not the case. Only passengers are allowed inside the airport. In the beginning itself, there is a check. So the protocol is slightly different. So Sydney Airport, anonymous access is allowed. So the premises can be accessed by anonymous objects or anonymous users, not objects, users. These are the objects or different resources. Security professionals, airport staff, everyone has access to the premise. The gun access, let me draw that in a different color. The gun access is specific to law enforcement. Only law enforcement has gun access. Say for example, federal police or local police, depends on the scenario. If it is in a country like India, a lot of army officials, part of defense, is normally present in almost all the airports for security purpose. Now, who has access to planes? So this is a plane. Pilots should have access to planes. Air crew should have access to planes, and passengers should have access to planes. That's the normal scenario. Access to planes. Plane's cockpit. Only pilots have access to cockpit. Only pilots enter into the cockpit. Plane food storage. Only air crew has access to that. As you can see, there are so many different access controls are in place in a scenario, a secure scenario like airport. Very evident. And all these users, almost all these users are authenticated, but they don't have the similar access. They are all authenticated users. Pilots needs their ID card to prove that they are pilots. Same with air crews. I'm pretty sure they will have their company ID card for their special entry into the airport. Passengers have tickets, then only they are allowed into the plane. I'm pretty sure pilots will have some kind of special authentication mechanism and proving that they are pilots so that they can enter into the cockpit of the aircraft. Same with all the staff, security professional, and I'm pretty sure law enforcement will have their own special IDs. Now by design, people who are not authenticated, the anonymous people, is allowed to access the airport premises, certain part of the airport premises in certain airports. This is not possible in certain countries like I mentioned. But a lot of software allow access to certain things anonymously without logging in. Now what we are discussing is the bottom of role-based access control or authorization. So what are roles here? What is the access control? Let's have a look. Roles are right here. Pilots, air crew, passengers, airport staff, security professional, law enforcement. Those are the different roles available. Role-based. The access control is based on role, not based on users. All the pilots can enter into the cockpit of the aircraft. All the law enforcement can hold guns. They are allowed to use guns in an airport. Very sensitive thing in an airport. Highly secured environment. So there are a couple of things here. One is making sure that the authentication is done properly and validated which group that particular user is part of or which role. In this discussion, I'll be interchangeably using role and groups, but it is not true, especially something like a cloud scenario in which we will see shortly the difference. But from this theory perspective, that difference is not very important. Groups and roles, they are kind of similar thing from the perspective of this particular discussion. Both are pointing to a group of users or a collection of users. For example, pilot. Pilot is, at the end of the day, a collection of human beings. Now, one question. Is it possible to have a non-human being, a non-human entity, be part of a role? Let's take the example of airport. Think about it. Pause the video and think about it. The question is, all these are human beings, pilots, at least as of now. I'm pretty sure that's going to change in the future, but in the year 2025, when I'm recording this video, at the time of this presentation, all of these things are humans, aircrew, pilots, passengers, staff, security, everything is humans. How about non-human entity? Can it have access to any of those things? The answer is yes. For example, the check-in terminal, the bag check-in terminal. For example, in the case of Qantas Airways in Sydney Airport, the bag checking terminal has access to the bags. So you have the bags here and there is this bag checking terminal. It has access to the bags. Once you check in the bag, there is no humans available. There are so many airports like that. Again, airports like Bangalore, for example, is slightly different. There is always humans present to help. But in Sydney, that's not the case. You check in your bag by yourself. You collect the sticker, stick it on your bag, put it into a check-in counter. The bag is automatically taken port premise. It should have certain access to the plane so that it'll keep the bag in the plane, the check-in bags inside the plane. So my point is, some of these entities which are non-human also can have access to certain roles, which is a very important point right here. So roles are not specific to human entities. They can be softwares, services, computers. All this can assume a role. Very important thing to consider. Now think about designing a software system for an airport. You need something like pilot, airport staff. All these different roles or groups of users are needed. Then you need to have a authentication mechanism to authenticate these users. ID, username, password, all different types of stuff. And there are different objects. So these are different objects inside the system, the airport. Objects are resources. So let me write that down. Objects or resources. Now, one more thing worth mentioning here is that let's take the example of the plane cockpit, which is an object here. Now, in the plane cockpit, you can do so many things. You can view it. So let me draw that here. So you can view it. So view is an operation which can be done on a plane cockpit. You can operate it, operation. You can drive the plane. You can take off, landing, all that kind of things. Now, someone has to clean this thing. Cleaning. The plane cockpit has to be cleaned. Otherwise, it's going to get dirty. Now, think about this different operations which is done on same objects. Do you think it should be done by same people? I don't think pilots are gonna clean the cockpit. Again, role-based access control is based on certain operations performed on the object. Very important thing to consider. Certain entities can perform certain operations on objects. For example, a janitor can clean the cockpit. So he need view access to the cockpit as well as he need clean access to the cockpit. But he should not have this particular access, operation access. He doesn't know how to fly a plane. Now, a pilot probably can have all these access, although he may not clean it, or he can simply view access and operation access. Again, very common thing in our real world, which is exactly what in our software world also does. Objects have operations, and that operations are performed by different people. In many cases, this boils down to certain APIs or application program interfaces or functions, if you will. A piece of code which is exposed by this particular object. We'll see all these things when we discuss some solid examples like AWS IAM. But the point here is that objects have operations and the operations are different for different users from an allow perspective. Now let's erase this diagram and generalize what we have discussed so far. So in the system we have different objects or resources, and objects have different functionalities or APIs or whatever it is. It exposes different capabilities. And we have users. So users are here, different users. Now there are different roles present in the system. Roles or groups, whatever we call it. And there is mapping. What subset of APIs of a particular object can be called from a role. For example, in this case, object 1 has A1, A2, and A3. Role 1 can access object 1's A1 and A2. So there is a mapping. Another mapping is what are the users which are part of R1. So this is user 1 and user 2. Like that, there is R2, R3, and R4, and so on. Object 1, object 2, object 3, object 4, A1, A2, A3, A1, A2, A1, A2. And there are so many users out here. This is the users. And this users can have computer. This users doesn't have to be humans like we discussed. It can be a software sitting there. It can be a chip running some code. It can be any service, pretty much has a number discussed in the authentication session. But in that, we'll be mentioning who is part of which group. So as part of the role-based access control, so this is called a role-based access control. Basically, we keep mainly two information. Which user is part of which role? That is information number one. And which role can access what resource and APIs of that particular resource. So for example, O1, A3, in this case, let me draw that in a different color. O1, A3 is not accessible by R1. By default, most of these things are denied unless we explicitly allow it. Depends on the actual system we are working, the actual role-based access control we are working. Otherwise, normally it is not allowed. Now, one more thing to mention here is that this role can contain other roles as well. So there is a nesting that is very common in very advanced role-based access control systems. For example, role 1 can contain role 2 and all its users for that matter. Just like any other user, it will behave like any other users. Groups within groups. Very common in Active Directory. A lot of softwares has complication with that nesting when it reaches to a certain level. That's all implementation details. It doesn't worry much, but the idea is very simple and straightforward. So what a role can contain? It can contain normal users, computers, other services, systems, software, and also other groups and roles. Depends on the system we are dealing with, actual implementation we are dealing with. So this particular pattern we are seeing here is very common in a lot of advanced software systems, server-side software systems. All cloud. If the cloud doesn't have this, it's not really a cloud. All cloud, GCP, AWS, which we will see. Azure has a slightly more advanced version of this. We'll see that as well. Azure Active Directory, which is kind of the Active Directory implementation of Microsoft, which is there in the cloud. Basically includes AWS IAM, Identity and Access Management. We'll see that in this lesson itself. Azure AD we will look into it when we discuss SAML. And everything like GCP, vSphere, Kubernetes. The Kubernetes ABAC is a typical example, open source. If you want to look at an open source implementation, this is a good example, Kubernetes ABAC. And it is a typical example of this pattern we are discussing here. Pretty much all the server-side softwares out there has some kind of ABAC or integration with an ABAC system. There are software products which specifically focus on these things. That's what their bread and butter. For example, Okta, ForgeRock, Ping. These are all implementing this thing, what we discussed here, along with the authentication bit. Users can decide what is their object and services. Users can decide who are their users, and they can configure roles and permissions of that roles. By the way, this is also called permission or access grant permission. Depends on the system we are discussing here. The terminology slightly changes. For example, roles, groups, permission, privilege, access grant, objects, all these different things are used in a different, slightly different way. Principal is another jargon you will see. Principal is normally for a user. It's a common name for all kind of users, or potentially can be a user. A role can be a principal. So don't get confused with these jargons. This is the basics. All you need to do is to map the jargon to one of these things you're seeing in the screen right now. So you will see all the jargons, different jargons used in different products. The biggest thing is that due to conflict between intellectual property, they try to name it differently so that their product looks different. That's where most of the jargons comes. Otherwise, everything would have named exactly same. Now, one more jargon I would like to explain before we wind up this particular blackboard is something called policy. Policy. I think this is coming from, again, historically speaking, Microsoft Active Directory group policy. The idea is very simple. We already discussed. Who can access what? That is policy is all about. For example, in this case, R1, role R1 can access A1 and A2. Let me draw that in a different color. So R1 can access A1 and A2 of object R1. So that is a policy. Policy of the system. Basically, rules. And that policy is applied on this particular role. And when the user becomes part of that particular role, in AWS terms, it is called assume a role. User can do whatever the policy is allowing it to do. So the term policy refers to what the role or the group can perform on different objects. Again, slightly different terminology, but ultimately it is more or less the same thing. Now let's have a look at the solid example of a production level role-based access control. In this case, we are going with AWS IAM, Identity and Access Management. Almost all the bells and whistles we have discussed here is present in that. So it'll be a good playground. Initially, I was thinking of Kubernetes because it's open source, but it doesn't have all the bells and whistles. It is more simple compared to IAM. IAM has all the complicated things. We can go into any level of detail, and it's more visual. Azure Active Directory, we will look into it, not in detail. These are all things worth its own training, but we are going through the basics. Once you know the basics, all you need is clicking around. Azure AD or Azure Entra ID, the new pet name for Azure AD, is very similar to all these products right here, which offers authentication and authorization. And we will see some of them in future lessons. Right now, let's go to AWS IAM and let's have a look how these things are implemented. So this is the logo of the AWS console, the web console of the AWS cloud console or management console. Just the UI to manage everything in an account. I'm not giving you much of an introduction about any cloud for that matter, but we are going to discuss this from the perspective of what we have known so far. For us, everything is objects and resources. So right now, we are going to look this from a security perspective. The first level of security here is the SSL itself. If you look here, the connection is secure. I don't have Fiddler running here, so it should be a proper certificate if I click on this. And the certificate is valid. So this is the first level of check. If I click on that, I'll get the CA name and things like that. Amazon root CA1. This should be there in my trust store. It should be there in all the trust stores. So my computer is trusting, or the browser is trusting, this particular CA1 right here. And this certificate is signed by that particular CA. So that is the first level of security I'm having. Even before logging in, I know that the username and password I'm giving is indeed to this particular fully qualified domain name or CNAME. So that is the first level of security here. This is the first and foremost level of security. If this is compromised, everything else is going to be compromised. Whatever information I am going to give here. Suppose if there is multi-factor authentication, the man in the middle will get that information as well, and he will be able to log into the actual web console of the AWS. So complete compromise of the system if this particular part is compromised. So everything is encrypted, the connection to the Amazon Web Services. Now I'm going to log in as a root user, and I'm going to type the username and password. There is no multi-factor authentication for this root account of this particular Amazon exercise we are doing because it's just a test account. We don't have anything valuable running in the account, but Amazon is enforcing for multi-factor authentication within 7 days. You will see all that warning once we log in. So this is the authentication part we are talking about, not authorization. I have typed the username and password. The typing of the username and password I have masked for security reasons and privacy reasons. But if you're doing this exercise, either you can create an account in AWS or you can type your username and password, the root username and password. Now we are not bothered about anything else. We are straight away going to something called identity and access management. So what is this all about is managing different users. Right now we are the root user, but this account has a lot of different resources. It has virtual machines, it has networks, load balancers, Kubernetes clusters, databases, secrets, disks, storage, S3 buckets. So many resources an account can have. By default, a root user has access to everything. So we need to have different users and different roles or groups inside the AWS to control the access to different objects. That is what this identity and access management is all about. For example, users. So these are different users who can access this particular account. You can create a user. This is a typical workflow in any kind of authorization system. So this is a typical authorization system. You will have a way to onboard users. It can be in the same system or in a different system. We will see a different system scenario after some time in a later lesson. But in this case, it is asking us to create a username. So we are going to create a username here. Test user 1. Provide user access to AWS Management Console, which is the console we are looking at, the Cloud Management Console. So already they are giving some best practices right here. So there are different ways to manage these things. For the time being, we are going with I am user. We are going to create a custom password. I'm going to put a show password here so that you can see the password. Test pass $123. That is a password which I'm giving. I'm going to uncheck this. These are all typical user creation questions. I feel like I'm filling up the AD user creation form. This is exactly similar to that, the Active Directory. Now, the user is going to get created. This is where the interesting things comes. What that user can do. Does it have the admin access or something else? Now, there are different options are there. Add user to a group which user is going to be part of, and that user group will have some permissions and policies applied to it. Same thing we have discussed in the Blackboard. Copy permission from a different place altogether. Attach policies directly. So it is not really recommended. In this case, we are going with attach policies so that we can learn a couple of things. Now, once the policies are available, as you can see here, there is so many options are here. As you can see, there are 66 pages of this thing right here. And one page itself is having so many different things. Now let's click on here. If you look at this, Access Analyzer Service Role Policy. What it does? It is a policy. What is that policy is having? That policy is having allow access to a different resources right here. Let's have a quick look at this. This is kind of the real stuff, real implementation of a very complicated system we are looking here of role-based access control. DynamoDB, that is a resource. That is a kind of object, a type of object inside AWS DynamoDB. It's a kind of database, NoSQL database. Doesn't matter to us, it's an object. It is like the aeroplane we discussed. Now, what does this aeroplane does? This aeroplane does these many things. Get a resource policy, list streams, list tables, and probably a lot more things. But this policy right here, the access analyzer service policy, service role policy in fact, allows only these operations. This is the aeroplane and this is the thing that aeroplane does. Remember, I was talking about the actions, cleaning, flying, opening the door of the cockpit, all that kind of things. Like that, inside this particular resource type, which is DynamoDB, these actions are allowed. Normally, a typical policy is more complicated than this. I'll tell you a little bit about it. So in this case, in AWS, resource is a slightly different term. I'll explain. But idea is effect allow. This is the name of the policy, effect allow. And what we are allowing, action. These are the different actions we are allowing. EC2. EC2 is the pet name for virtual machines in AWS. These many things we can do in EC2. There are a lot more functions other than describe address, describe BYO IP siders, all different types of operations. Elastic file system, IAM. It's a pretty powerful kind of policy. So many different objects and operations. So this is the object. After the colon, it is the operation on that object. This is the aeroplane and this is the operation which can be done on that particular object. Flying, cleaning, landing, takeoff, keeping passengers, keeping check-in bags, all kind of different operations. Now, in the case of AWS, there is something called resource here as well. So this is very AWS specific thingy. Resource means in AWS world, it is the name of the object. It is very granular that way. This is why I selected AWS instead of something like Kubernetes, because Kubernetes is not this complicated. It is not this granular. So resource name means that you can specify a particular aeroplane, a particular flight number. Say for example, Boeing 738 on a Qantas QF68 flight, which is a very specific flight we are talking about. Very specific object with a name. It is not a random plane we are talking about. One specific pilot is only allowed to access and fly one particular plane in the whole world. That is kind of the stuff we are doing here. The resource name, what we are giving here. In this case, it is mentioned star, which means any resource of this kind of type, this policy will be applied. But a custom policy in AWS normally is very granular to a particular resource name by putting the correct resource name here. Very specific to AWS, but idea is very simple. We are pinpointing the access. The granularity of the access is being pinpointed to a one particular thing to make it way more secure. In this case, it is not the case. It is star, which means that every single object, doesn't matter what name is, as long as it has this kind of functions, it is allowed. That's the idea. So we can select this for the time being. We are just doing random things right now, not any particular purpose. Let me see if there is something with EC2 so that we can do something with it. EC2. Amazon EC2 full access. Let's click on that. We'll see all the EC2 related things and a couple of other things. So the main policy in this is EC2 star, which means that the operation doesn't matter. Any operation on EC2 resource or a virtual machine is allowed. A couple of other things are allowed as well. Elastic load balancing, then CloudWatch, auto scaling, and a couple of things like that is allowed. As you can see here, the AWS role-based access control is pretty granular in the sense that you can mention pretty much programming to pinpoint the object. Condition string equal to. Pretty much an if-else condition we are mentioning here. So that only if this condition is true, this allow will work. That's the idea. Technically speaking, you can pinpoint anything and everything. It's like a programming language, small world of programming language. This condition thing in AWS, very powerful as well as complicated. Certain policies you need to think it through, what really it does, what really it allows. Although I deal with these things on a daily basis. So the idea here is that allowing certain things in a very specific granular way. Now I'm going to give EC2 full access to this particular user and going to click next, review and create. The username is testuser1. We have given a password, testpass123. Require password reset? No. And this is the policy which we are applied, the permissions of that particular user. It's a very inefficient way to do this, at least in the sense of AWS, but I just wanted to show you something and play around it. So console password, testpass123. That's our console password. And this is the sign in URL. This is the account number of this particular account. And this is the test user. You can click on view user and see that particular user. And if you look at the account number, you can see that it's the same number as it is here. This is all very AWS specific things, nothing very important to us. But we are going to use this to log into this account. So it is good to know. So what I have done is I have gone to that URL right here. As you can see, the URL has automatically changed and the account number has come here. And then we can put the username and password, testuser1, and password is this, and sign in. If I show password, same password, and we signed in. We signed into the same account. The previous one was a root account. So the root account is here, which has permission for everything. Now, this is not a root account. As you can see, we are already getting access denied. Service catalog list application, that is getting access denied. Why? Because that particular object, this particular object, and this particular action of that object is not allowed. The janitor is trying to fly the plane here. Is he allowed? No, he is not. Only pilot can fly the plane. Another thing right here, a passenger is trying to get into the cockpit of the flight. He's not allowed, as you can see here. So get cost and usage. That is not part of that policy we have seen, EC2 full access. If you want, you can create an account and review it, but it is not. Now what we have access is EC2. So let's type that in, EC2 full access. We have given EC2 full access. This thing should work. The reason this thing should work is because we have allowed that thing. We are able to get in the console. We don't have any EC2 instance running. If you want, we can create an EC2 instance, delete, all that kind of things we can do. In this case, the passenger is, after the security check, the passenger has gone into the passenger seat and sitting in the plane. It's like that right now. Now, if you try anything else, nothing works. So for example, if I'm going to type I am here, and click on this one, I should get an access denied. See, I'm getting access denied again. I am get account summary. Normally AWS is very good with this. AWS give you the function name which you need. So this is the object and this is a function you need permission. And if you add that in the policy and attach to this particular user, this error will go out. And it clearly says the ARN of the user and things like that. ARN is just the username, the fully qualified username. This is the account and this is the type of the object and things like that. Doesn't matter. We don't have access to all these things and we are getting access denied. So going back to the admin console or the management console with the root permissions, the one we've been seeing so far, where we have all the permissions. What we have done, we have created a user in AWS, which is a test user. And we attached a permission, a set of permission, which is this, to that user. We have not created any role or we have not really done any role-based access control. In fact, when we created the user, it was already telling that you create a group or a role to do it. that is the right way to do it. That's what we are going to do next. We are going to discuss roles, policies, and a couple of other things available, especially identity providers. Identity providers probably we will discuss in the SAML session. Probably we will have a look into it and a couple of other things. But mainly we want to discuss the roles and of course user group as well. But normally user group is not really used in AWS anymore. It's kind of an obsolete thing, but good to know the concept. It is the roles which we would like to discuss. So to conclude, we have seen the basics of authorization. We need to continue the demo further to understand more about it. And that's exactly what we are going to do in the next lesson. We're going to continue the demo and explain a couple more things in the context of AWS IAM.